be sure that you leave your team reference document on the workstation. Don't take it with you, and you shouldn't be going anywhere right now because we have Coaches Award Ceremony starting shortly. Okay, if everyone would please take your seats, we're ready to start the Challenge Award Ceremony. So everyone take a seat, please.
Good morning. Welcome to China. You're at the ICPC Challenge Championship powered by Alumni.
We are facing huge challenges, just waiting to be solved by best of us.
The business of helping people prosper, for there to be enough and more than enough.
I think I need to be very lucky for this.
But in general, I'm quite happy with the trip because it's very nice and very well organized.
I think I will get into the top 10 because I get the top 10 in the previous content.
So congratulations on taking on the challenge and doing such a wonderful job of solving the problems that have been presented to you. A wonderful job of solving the problems that have been presented to you and everyone on the globe because of the digital age that we live in. So thank you very, very much.
At this time, I'd like to welcome back to the stage the ICPC Challenge Director, Tomasz Cerny.
Thank you, John. So congratulations on completing the dress rehearsal. I hope you are not too washed out as you are looking forward tomorrow for the 46 and 47 World Finals. However, now we have some exciting events going to happen in the next few minutes. In fact, I have to compete with time, so I will be speaking, hopefully speaking a little fast so that we catch up the time that we need for the upcoming events. So please, I need your attention right now, and of course, all the teams, please stay at your stations. I see many teams are moving around. Try to take a spot at your station. So, we are about to award the World Finals ICPC 2023 Challenge powered by Huawei Awards Program. And I have a Bill, and he has some announcement to make.
You know, we always put people first. And Jelani Nelson, do you see him back there? His pack is missing, and it's black. Is that what? Yeah. Jelani, come up here and tell us what that's like.
Here we go.
Oh, I see. Jelani, this is Jelani Nelson, and he heads up the ICPC Alumni Speaker Program and several other things here. And his backpack was over in this area. Is that correct? Here you go.
Yeah, thanks, Bill. Yeah, I left a black backpack that says Google Research on it on one of the chairs near the entrance. and it's no longer there. So if anyone has seen it, please find me. I'll be near the entrance where the stage is.
Thank you. It's Jelani's black backpack, and it has his passports and a number of things in it. So do everything that you possibly can to search around and see if you can find that for him. Thank you. Again, ICPC puts people first, and right now, it puts students first among people. So why don't you put the students first with this wonderful challenge? Thank you.
Thank you, Bill. I have 2 microphones now, so I'll hand one to Tanya. Okay, so where have we been? We have been hiding 2 minutes ago, right? Fine. So let's try to fight with the time. And I have this important announcement to make. I'm going to call top 8 teams in the 3rd place, top 8 teams in the 2nd place, and the top 8 teams in the 1st place. But I'm also going to call top 3 3rd place coaches, top 2 2nd place coaches, and the top 1 1st coach. So please, when I announce your achievement, please come nearby to the stage, and you will be eventually here on the stage taking pictures. So what do we do first? We will call the bronze awardees, then the silver awardees, then the gold awardees, and in between, we will invite the coaches as well. All right, everyone gets that? That's our protocol. So let's begin. But first, I would like to ask Huawei to come to present the awards. And it's my pleasure to invite Luo Wei, the HR manager of Warsaw Research Center, Rafał Czehab, the problem co-author and the software expert at Reston Research Center, and Lin Chang, another co-author of the problem and the software expert of wireless BU Huawei. Come on stage. And we will invite 2 more core individuals that contributed to the ICPC challenge success. So I would like to invite Ivan Kazmenko, the co-author of the ICPC challenge, and Veronika Sobeleva, ICPC Director of Development. Please come to join us. All right. Our crew is full and ready on the stage. So I am excited to move to the 3rd place status awardees. So here we see what the 3rd place award is. And as I see that, you are not going to receive it on a stage, but please go to the Huawei stage at the chill zone, and it will be shipped to your home. So you don't need to worry about it, just that you know how to pick it up. Okay, we can go to the next slide, and I'm excited to call to come close to the stage 46, Taras Shevchenko, National University of Kiev, 47th, University of Warsaw, 47th, St. Petersburg ITMO University, 47th, Charles University, 47 Xi'an Jiatong University, 47 Belarusian State University, and I don't see you coming, guys, so please quickly come on by to be ready. Okay, I believe I ended with the Belarusian State University, so then we have 47 Universidade Federal de Minas Gerais, and 47 Universidade de Guadalcanto DCNE. So if we are ready, I would like to first invite the 46th Taras Shevchenko National University of Kiev. Please come on stage. I think you want to go in between, so it might be better. And you are the photographer, so Guy, you do the script. Do you want us more close here? They are good as they are. Congratulations, the Taras Shevchenko National University of Kiev. Okay, let's go to the next one. We are good, guys. Thank you. 47th University of Warsaw, please come on stage. Congratulations. They want a little excitement from you guys. So a big smile. Congratulations. And we move up to the 47 St. Petersburg ITMO University. Please come on stage. And I can hold your bag. It will be nicer without it on a picture. I will give it back, I promise. Okay, you got it. Thank you. And we are moving up to the 47 Charles University. Please come on stage. Congratulations. Thank you. And we are moving up to the 47 Xi'an University. Please come on stage. Congratulations. Xi'an University. Thank you. Moving up to the 47 Belarusian State University, please come on stage and congratulations. The Belarusian State University, congratulations. And moving up to the Universidad Federal de Minas Gerais, come on stage and congratulations. And we have just two of them. Congratulations twice. Next time we will divide by 2 and multiply by 3, and I think they are unbeatable. Moving up to the 47 Universidade de Guanajuato DCNE. Please come on stage and congratulations. All right. Congratulations again. And we are moving on through the line of the second place status. However, I would like to thank my Huawei friends, and I will make a new crew. So if you can, exchange, thank you, with the Wang Lei, the HR Director of European Research Institute, please come on stage. Xi Peng, the HR Director of RRI, and Xia Huang, sorry, my last name is also difficult, Cao Huaxing, Problem Co-author and Software Expert in Wireless Business Unit and Huawei. So we have the team ready, and we are ready to award the second place teams. Okay, I would like to, and I will read again all of you, so please make sure that you come on stage as your name is read. So 47 Seoul National University, 46 Nanjing University, 46 École Polytechnique, 47 Harbor Space University Barcelona campus, 47 Lund University, 47 Tsinghua University, 47 Peking University, and 47 Nanjing University. Please come by. And I will make you more space. All right, if we have the Seoul National University, you are more than welcome to come on stage. Congratulations, second place. Seoul National University, congratulations again. All right, thank you. And as we are moving quickly, I'm going to the 46 Nanjing University. Please come on stage. Congratulations. And a no serious face, you want to smile. Nanjing University, congratulations. Okay, we are moving up to the 46 École Polytechnique. Please come on stage. Congratulations, École Polytechnique. École Polytechnique, congratulations. We are good. 47 Harbor Space University Barcelona campus, come on stage and congratulations. Harbor Space University Barcelona campus. All right. We are moving up to the 47 Lund University. Please come on stage and congratulations. The Lund University. Congratulations. And we are moving to the 47 Tsinghua University. Please come on stage. All right, congratulations. And big smile, you are bringing the second place. Tsinghua University. Congratulations. And we will be moving up to the 47th Peking University. Please come on stage. Congratulations. Peking University, second place. All right, thank you. And we are moving to the last in the second place spot. Well, the first in the second place spot, but the last team to announce. The 47 Nanjing University, congratulations and come on stage. Nanjing University, congratulations. Thank you. All right, I will thank again to my Huawei friends and we will exchange the crew. So I would like to invite the following Huawei representatives. Vicky Zhang, the Vice President of Corporate Communications Department, please come on stage. Wang Aimeng, the Vice President of the Institute of Strategic Research Huawei and the Director of the Contest Management Department. And Bill McCall, the Director of the Computing System Lab, Zurich Research Center Huawei. Come on stage. Okay, I think we are sort of ready for the first teams, but you know, let's do the coaches. Let's do the coaches. So, we are recognizing 3 third-place coaches, and it's my pleasure to invite on stage all of them at once. All of them at once. So if you hear your name, just run to help us with the time. So, Andrei Lopatin, 3rd place, St. Petersburg State University, congratulations and come on stage. Carlos Segura Gonzalez, Universidad de Guadalajara, DCNE, please come on stage. Bernard Lynn Hilmerson, ETH Zurich, please come on stage. The second place coaches, Nivan Ferreira, Universidade Federal de Pernambuco. Please come on stage. Sejin, MIT, Massachusetts Institute of University. And finally, the first place coach is Gennady Korotkevich, St. Petersburg ITMO University. Why am I not surprised? Why am I not surprised? Congratulations to all of you wonderful coaches. What a pleasure your students have to have such a capable coaches. And since the team is full, please let's give them a big round of applause. Andrej Lopatin, Carlos Segura Gonzalez, Bernard Lynn Hilmarsson, Nivan Ferreira, Sejin, Gennady Korotkevich. Congratulations. And it seems very good. Thank you. So I will keep my crew on stage and we will move quickly to the top 8 teams in the first spot, in the first place. Again, I will invite you to be close by the stage and then I will be inviting you one by one. So, let's go for it. 47 National Research University Higher School of Economics, 47 Kyoto University, 46 Peking University, 47th University of Tokyo, 47th University of Science, VNU HCM. And I have to apologize, but I don't see the first, second, and third. I guess I have a problem in my script. Oh no, we will be recognizing them tomorrow at the secret location of the final ceremony. So the top 3 are not invited today, but I'm sure you will enjoy your time tomorrow. So if I have the 5 teams here, please come on stage. National Research University Higher School of Economics. Congratulations. '47 National Research University Higher School of Economics. Come on stage. Congratulations. First place. All right, and we are moving to the next. The 47 Kyoto University, please come on stage. Congratulations, Kyoto University. What a wonderful accomplishment, first place. Congratulations, Kyoto University. All right, and we are going to move up. And we are going to the 46 Peking University. Congratulations, Peking University. First place, Peking University. And if you paid attention, we got both Peking Universities, the 46th and 47th as well. Congratulations, what a great accomplishment for the university. All right, and we are going one spot up to the 47th University of Tokyo. Come on stage. Oh yeah, that's a great excitement. I like that. I like that. The University of Tokyo, first place. Outstanding. All right. And I'm about to invite the next team on stage. So let me invite the University of Science, VNU HCM. Please come on stage. What a wonderful job you did, guys. And I like your excitement as well. That's the right spirit. The University of Science, VNU HCM. Okay, let me remind you one more time. You are not picking up the prices, but you are reaching out the Huawei at the chill zone in their booth, and you will fill out your address and they will deliver you the prices. Thank you everyone, and thank you my crew that was on the stage. All right, I have a few more things to mention. Nothing of this would be possible without the great team we had to prepare this challenge. So I would like to name few who were certainly the big figures helping up with this challenge. Mike Mirzayanov from Code Forces, and of course Code Forces played a very significant role. You were submitting to it, so please get engaged with them. Ivan Kazmenko, we had him on stage. Matvey Kazakov, Nick Wu, Boris Minayev, Mikhail Dvorkin, Nikolai Kalinin, Veronika Soboleva, Melissa Elliott, and Jackie Luscombe. We also had a great team from Huawei: George Kwao Zi, Sofia Li Jing, Kong Donggon, Lin Chang, Rafał Chehab, Chen Mugi, Zheng Liming, and many thanks to many other Huawei engineers. Thank you. And of course, if you feel like, you can join our team for the next finals. Finally, I would like to thank to you, to all of you that you have competed and you worked hard. So thank you, and let's make a big applause for all of you participating. I have last two announcements to make and I'm out. First of all, tonight at the Chill Zone, meet the ICPC alumni startups, and we have their Cognition AI, Lighter, Primitivity, and Ramp. Engage. Today you compete, tomorrow you collaborate. Make sure you make the social connections, because these last. Okay, I hope Jelani is ready, because we have some outstanding talk, and I will stop to bothering you. I'm sure you are excited about. This is hosted by Jelani Nelson, the professor at UC Berkeley. The stage is yours.
All right, can everybody hear me well? Good afternoon, everyone. My name is Jelani Nelson, as mentioned, and aside from being a computer science professor and ICPC coach at UC Berkeley, I am also director of the relatively new ICPC Alumni Speaker Series. This series started in the pandemic in summer 2020 with a series of online talks by algorithms researchers, most of whom were ICPC alumni. A big thank you to Bill Poucher, Lisa and Jeff Donahue, Veronika Soboleva, and especially Lydia Perovskaya and the ICPC Live team for supporting this talk series. I am pleased to introduce you to this World Finals Alumni Series speaker, Jakub Pohotsky, who very much comes from this community. For example, in 2012 alone, he won first place in Google Code Jam, second at the Top Coder Open, and second place and gold medalist as part of the University of Warsaw team here at the ICPC World Finals, which that year, by the way, was at Warsaw. And that was just 2012. After finishing at Warsaw, Jakub joined Carnegie Mellon University to do his computer science PhD. There he did fantastic research in algorithms, especially in randomized linear algebra algorithms and algorithmic spectral graph theory. For those who don't know, spectral graph theory is about determining interesting properties of graphs based on spectral properties. That is, properties having to do with eigenvectors and eigenvalues of its related matrices, such as the adjacency matrix. He also there served as an assistant coach for CMU's ICPC team. After finishing his PhD at Carnegie Mellon in only 3 years, Jakob joined my group as a postdoctoral fellow while I was on the Harvard faculty. And I noticed, machine learning was not my area, but I noticed he started to get a machine learning itch around that time. And he left the postdoc in early 2017 to join this relatively young nonprofit at the time called OpenAI. As mentioned, he is now serving there as company-wide director of research, where he engaged in such activity as leading the training effort on GPT-4. And to quote a tweet last year from Sam Altman, the CEO of OpenAI, I'm now quoting Sam, GPT-4 was truly a team effort from our entire company, but the overall leadership and technical vision of Jakob Pohotsky for the pre-training effort was remarkable, and we wouldn't be here without it. That was the CEO of OpenAI saying that last year. So without further ado, let's hear directly from Jakob, who will present his talk, Scaling Up Deep Learning. Thank you.
Thanks, Jelani. Hi, everyone. Wow, it's really great to be here. Today, I will talk about some work others and myself did on building and scaling up deep learning systems. I think deep learning is the most fascinating technology in the world. And I don't think we've seen everything it has to offer yet. I would even say I don't think we've really seen much compared to what we will see in the future. I will talk about our work on a deep learning-based bot that could compete with professional players at the game of Dota. And I will talk about building GPT-4, the model that powers ChatGPT. And first, let me talk a bit about my journey. Because for me, it really starts here, with this community, with programming competitions. For me, at the core of these programming contests, at the very heart of what we do is this question, what are computers capable of? What can we make computers do? Right? So when you open a new problem and you read it, and maybe it's a difficult problem, and you go, wow, can computers even do that? Can I make computers do that? And can I go from these inputs to these outputs in fast time? And then you think about it, and when you eventually crack it, and when you write a program that clearly demonstrates, yes, it's possible, and here's the computer doing it, it's the best feeling, right? And I became so passionate about this. And in high school, I could barely think about anything else. And I wanted to play in the big leagues, right? ICPC, and other major competitions of the time, like Top Coder and Google Code Jam. Topping the leaderboards, the Titans, Petr, AC Rush, Tomek. Right? And I wanted to learn how they think and how they manage to solve these extremely difficult problems under such extreme time constraints. And so I was extremely excited when I learned that Petr started uploading screencasts of how he solved top coder problems. So here's just a random screenshot from an early YouTube video Petr uploaded. But actually, before he started uploading YouTube videos, he would upload video files and he would post links on the top coder forums. Like raw MP4 files, and I would go and download them. It would be tough on my bandwidth at the time, but I would download them, and I would watch them end to end. And what I learned was extremely surprising to me. You see, my mental model of what you had to do to compete at this top level was, well, you're trying to solve these very hard problems in this very limited amount of time, so you have to go fast, right? And you just have to go, 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 go. Not that much time to think. You have to type really fast. You have to stay really focused so that you don't make bugs, right? But it's kind of all about speed, and it's all about just not losing focus. And watching Patch solve problems made something very kind of flipped my thinking about this, because the process, you could see that the way he would write the programs would reflect a deep understanding of the problem, and he would take care to really get the fundamentals right. And so this made me realize that competing at this top level is not necessarily just about avoiding bugs, but it's actually about creating these solid foundations. And you could write these beautiful, readable programs that really reflected an understanding of the subject matter. And to me, this was a revelation, and I loved it. And it made me fall in love with programming competitions even more. And I really wanted that to become my style, too. And so I practiced, and I practiced, and I practiced. And eventually, I got to a point where I got pretty good results in some of these big competitions. In 2012, representing the home team, together with my fabulous teammates, Tomek and Wojtek, we got second place at the ICPC World Finals. And that same year, I won Google Code Jam, which was a huge deal to me. After that, I didn't participate in programming competitions quite as much. And looking back in retrospect, maybe that was a pretty fortunate year for me to take a break, because that was around the time tourists became eligible to compete. When you solve a lot of these programming contest problems, you start to group them into categories. You look at the problem and you think, oh, this looks maybe like a simple greedy algorithm problem, and this looks like a dynamic programming problem, and this is kind of a math puzzle problem, and this is a sec tree problem. And among all these categories of problems, one group kind of stood out to me, one domain, because there was this algorithm that was, on one hand relatively simple, but on the other hand felt kind of magical, and it could tackle this wide class of problems that otherwise just felt completely inaccessible. And I'm not talking about deep learning, not yet, but I think there are some parallels to deep learning that I will talk about. But no, the magical algorithm I'm talking about is MaxFlow. So in MaxFlow, you're given a graph, and you're trying to find the maximum number of edge disjoint paths between a source and a sink. And there are many algorithms that you can use to attack this, but kind of the fundamental idea of the Ford-Fulkerson algorithm is you just find augmenting paths. So you find any path connecting the source and the sink, and you add it to your flow. And you're not allowed to use the same edge except going in the opposite direction. So you're able to reverse whatever flow you send through an edge. And it's a pretty simple algorithm, but at the same time, how come this kind of idea of augmenting paths and going through these reversed edges, how is it able to tackle so many problems? How can you reduce so many things to it? Why does it work? I found this so fascinating. It really came at this it really pushed the edge for me of what computers could do. And so when I learned there was a thriving scientific community focused on this problem and improving on this algorithm, I really wanted to become part of it. And so I went to do a PhD in theoretical computer science, working on problems around MaxFlow. And was that the reason that MaxFlow felt so magical to me is because it was a fairly general instance of high-dimensional convex optimization. So what does high-dimensional convex optimization mean? Well, high-dimensional just means many parameters. So you're optimizing the flow over these multiple edges, and you have to satisfy these constraints on the nodes. And convex means it belongs to this fairly broad class of problems where you can prove this this greedy algorithm of iteratively improving your solution actually gives you the global optimum. So, this was fascinating research, and there's really beautiful theory there, and a lot of progress has been happening. And you might ask, well, okay, but you maybe heard about convex optimization. And what does it really have to do with augmenting paths, right? Because when you first look at convex optimization, when you're first introduced to it, you're usually presented with this kind of 1D picture, here's a function, you're trying to find the minimum, and you're going to start at some point, and you're going to follow the gradient. So you're going to try to go in the direction of steepest descent. And maybe first you will take a big step towards the optimum, then you'll maybe take a smaller step. Maybe you'll bounce around the optimum a little bit. You'll eventually find it. But, where are the augmenting paths, right? Where's graph connectivity? What does this have to do with the problem I've been talking about? And, in a way, maybe there is not so much. Because the really incredible thing about max flow is the high-dimensional aspect of it. And I think the thing that I found so fascinating about it is that it really lets you visualize how high-dimensional optimization works in a way that otherwise would be very difficult for me to imagine. And so, maybe you've heard, someone has great 2D geometry intuition, someone has great 3D geometry intuition, rarely maybe someone has great 4D geometry intuition. Well, I think if you've thought a lot about graph algorithms, you can say you have an n-dimensional geometry intuition. And n-dimensional geometry really can feel quite different from what we've seen in the picture before. So the way I viewed this research was building this solid theory for what computers would be able to do quite a bit into the future, right? So maybe if we really understand this high-dimensional convex optimization now, maybe 50, 100 years from now, it will form the basis for what computers can do then, right? And they will be able to achieve incredible things that we haven't seen up to now. And in order to build something for the very long term, right, you really need to build on solid foundations. And so this convex part, this part that made it possible to prove theorems and really deeply understand what's going on, felt indispensable to me. And for that reason, I wasn't too excited about this kind of heuristics of the day. There was this fad in computer vision. People were very excited about this thing called neural networks, and it was cool, right? It achieved really good results on recognizing images, and it had these cool brain analogies, but you couldn't really prove it worked, right? And if you cannot really prove it works, how do you do research on it? How do you really build for the long term? So that's kind of how I viewed the world, until I was forced to reconsider. In 2015, DeepMind released AlphaGo, a deep learning-based system that was capable of defeating the best human players at the game of Go. Up until this point, Go was this gold benchmark, this last bastion of human ability, where humans could feel secure in their ability to defeat computers. Because the existing algorithms, tree search, this kind of brute force search of the state space of the game, just wasn't really applicable because of how complex the game was. The way DeepMind attacked this is they still use the same basic framework of tree search, but they use the neural network to guide the tree search. It was a very beautiful algorithm. And they showed that with AlphaGo 0 and Alpha 0, you didn't even need examples of how humans play the game. The algorithm could go straight from the rules to defeating the best human players. And so, I found this completely incredible, and it just didn't match how I was thinking about the world at the time. The way this neural network worked is it would take in an embedding of the Go board, and you would pass it through this complicated function represented by the neural network. And then it would produce maybe a probability that the game state was winning, or maybe a distribution over the optimal next move. And the way this worked, right? Like, this really was clear evidence that deep learning was not kind of just a fad somewhere on the side. It really was capable of achieving this very concrete, measurable progress in reasoning and really push the boundary of computer ability. And moreover, if you look at how the neural network itself was trained, right, the core of this whole process, well, it was optimized with high-dimensional optimization. It was the same basic idea of iteratively taking steps to improve it, going in the direction of steepest improvement. And the big difference from Max Flow was that it was not convex anymore. So you could no longer prove you're going to reach the global optimum. In fact, you weren't going to reach the global optimum, but it still worked. And to me, it was a massive difference, right? Because, well, on one hand, you have this thing that clearly works, that is clearly going to matter. But on the other hand, you cannot prove things about it. And how do I fit this into my worldview? How do I build for the long term on something that we cannot prove anything about? And this really forced me to change my frame of mind, to change my mindset from one of a mathematician to one of a physicist, right? Because when you have this natural phenomenon that you cannot quite explain, but it clearly matters, well, you have to figure out how to develop mathematical tools to deal with it. There's this nice quote from Einstein that mathematics cannot describe reality with complete certainty. And I feel it applies very well here. Because at the root, the problem I had with neural networks is you couldn't have mathematical certainty about how they worked. And you needed to accept that uncertainty and build around it and study observationally how these systems work in order to be able to make useful long-term progress. After AlphaGo, I became increasingly consumed by this idea of deep learning. I finished my PhD. I spent some wonderful time with Jelani, learning from him about information theory. And then I felt ready to jump with both feet into deep learning. And I joined this relatively young startup at the time called OpenAI. And at OpenAI, I was exposed to people with very different research backgrounds. For example, Ilya, who has for a long time really believed in this technology and has successfully predicted its success. Right as I joined, we were starting to work on a project that, to me, at the time, was the coolest project imaginable under the sun. You see, AlphaGo essentially solves two-player board games, or at least the kind where it's zero-sum and you have perfect information. It doesn't really get much harder than Go. And so there was this question, okay, like how do we push this technology further? How do we explore the boundary of what it's capable of? And the natural idea is, well, how about we solve the hardest computer game? Now, of course, what is the hardest computer game is debatable. But Dota is up there. Dota is a 5 versus 5 strategy game that is famous for its high skill ceiling. So you have players that play for tens of thousands of hours and continue to improve and continue to find new strategies. And another thing that was exciting to us about Dota was that it was quite clear that the methodology of AlphaGo would not quite apply here. Because the game is real time, and there is a huge action space, and you can take multiple actions per second in games that take over 30 minutes. And so you won't really be taken far by just applying tree search, even guided by a neural network. So there was another algorithm that was kind of simpler than tree search, called policy gradient, where you simply let the network play the game, and then you just reward it for things that went well. But there was this notion at the time that policy gradient doesn't really scale that well, and it's only been applied to much simpler games at Dota. So the approach we took to figuring out how to create an AI for Dota was, well, we figured, well, okay, we're going to take policy gradient, we're going to scale it up until it inevitably fails and stalls, and we're going to study why. and then maybe we're going to develop a better algorithm based on our findings. And to accomplish that, together with my great friend and longtime collaborator, Szymon Sidor, we started developing this framework called RAPID to scale up reinforcement learning, because it really gets a little complex with all these games you have to play and sending around observations of the game and so forth. And as we were building the system, we really were determined to see the limits of how far we can scale policy gradient, and so we wanted to build something, again, with solid foundations. And you know, at one point, we actually spent a few days just obsessing over the design of the config files for Rapid. And at the time, we were kind of like, oh, you know, are we overdoing this? Are we taking too much time? Are we moving too slowly? And we would laugh about this later when it became clear that, you know, the good abstractions of the config files returned on themselves many times over as we were designing increasingly complex experiments and systems. And, you know, it's very much like this learning from the patch screencasts, that really you want good abstractions in order to tackle these complex problems. And to our surprise, scaling continued to work, and we continued to increase the batch size for this system, and it continued getting better at Dota. And you know, as we scaled and scaled to increasingly serious amounts of compute, we started to realize that OpenAI would have to become a company focused around scaling. And we would have to be focused on great software engineering and, you know, the necessary resources, and also building this long-term understanding, the science of deep learning that would allow us to scale. And I think it's useful at this point to talk about why this sort of building understanding is necessary to scale, and what is the role of bugs in deep learning. Because I think bugs in deep learning function a little differently than bugs in many other domains. So, for example, if you make a bug at the World Finals tomorrow, which I hope you don't, but you know, realistically, some bugs, some misconceptions will happen. It's okay, you can fix them. But when you send the wrong solution, you will get a status code, like probably wrong answer, maybe some other status code, but you will get some clear feedback that there is an issue with your solution. And similarly, when you're building a production system, like maybe something for clients or some backend system, you know, maybe you wouldn't get as fast as immediate feedback, but still, if there is a problem with your system, there probably exists some input, some condition under which it won't behave. It clearly will behave differently than it's supposed to. And so again, you will get this clear feedback that there is an issue with your system. But with deep learning, it's a little bit different, right? Because, well, first of all, we don't expect neural networks to behave completely flawlessly. So when you see the network make a mistake, you don't know if it's because you made a mistake training it, or if it's because you know, it's just not smart enough, or maybe there is some pattern in the training data that causes it to act this way. And similarly, even if you do make a mistake, you know, this training process is fairly robust, and the network will still learn to do something fairly reasonable. So it's pretty hard to tell if you even have a bug. So to illustrate this, let's to illustrate this, we'll go through a simple example. But really, you know, but before that, you could really ask, why do bugs even matter, right? Like, you know, if I cannot even tell I have them, you know, maybe it's fine, right? Because maybe I just, you know, train my network with a couple bugs, and you know, it does something reasonable. It's fine. And, you know, to an extent, I think there is some truth to that, because what bugs in deep learning really hamper is the ability to scale. So rather than prevent your system from working completely, they will prevent you getting returns on increasing the compute you use to train your system. And we've seen that in AI, compute really matters, and it really is key to getting these really great results. And to really illustrate what I mean here, let's build a very simple machine learning system and study the impact bugs have on it. So let's say we're trying to find San Francisco, and we're going to have this device that returns an approximate location of San Francisco, maybe within a 500-kilometer radius. So here are a couple samples with the green points. And we'll also have a bugged version of the device that also returns samples around San Francisco, but not actually centered around the city, but centered maybe 10 kilometers away from it. So of course, if you take a couple samples from the correct device and the bugged device, you're not really going to be able to tell the difference, because the bias is much smaller than the variance, right? The noise in their measurements. And similarly, when you try to actually estimate the location of the city by taking the average of a couple data points, from the correct device, maybe you land here. From the incorrect device, maybe you land here. So, what did we learn? Like maybe San Francisco is somewhere in California, maybe somewhere in the Pacific Ocean. And the bug didn't really matter. And it's fine. But then it really changes when you try to scale it up. Because what happens when you take 1 million samples, right? The correct device will land you square in the city. The noise will be almost eliminated. But then the incorrect device will land you, maybe in Berkeley. And so even though the incorrect device with sufficient compute can tell you exactly where San Francisco is, the bug device might never reach the city boundaries. Right? And we can even draw a plot, and we can see that kind of as we increase the number of samples, the bug starts to matter. So at the beginning, when you're taking only a few samples, you cannot really tell the difference, and it didn't matter that the device had a bug, but when you're trying to really push it, it makes all the difference. And and these bugs, they can be caused, by typos and so forth, but I think more commonly they are caused by incomplete understanding of the system that you're building and not realizing some constraints that you're imposing on the system just by the virtue of the abstractions you're using. And to illustrate that, let me talk about an actual example that we had while building the Dota bot. So we were building, we continued to scale policy gradient on Dota. And eventually, we felt ready to present a version of our bot that could play a 1-versus-1 version of the game. And we went to this fantastic event called Day International. It's a huge event organized by the creators of the game. Great atmosphere, lots of people there, all the best professional players. It's kind of like the ICPC World Finals for video games. And we went there and we were gearing up to set our bot up against the best professional players in Dota. And as we were getting there, we got the opportunity to scale the system much further. But even though we scaled it to tens of thousands of CPUs, we weren't using GPUs at the time. We realized it was not learning fast enough. It was learning faster, but it wasn't going to be good enough to beat the best human players. And so we realized we need to try something different, and we need to think about, is there something that is bottlenecking the scaling of this model? And we realized that maybe a possible bottleneck that we imposed to the system was we were training it to always optimize the state of the game 10 seconds from now. So it would play to maximize its rewards within the next 10-second window. And the rewards were some heuristic combination of gold and health. And we realized that because we scaled the algorithm up so much, maybe it could tackle a much harder optimization problem. And instead of looking only at a 10-second window, maybe it could look at a much longer window. So we bumped up the window beyond 1 minute. And we let the model train. And then the next day, we were very anxious to see what it learned. So we set up a playtesting match against this friendly professional player that was helping us test the model. So you understand the setup of the game. It's a 1-versus-1, so you have these two players controlling two heroes. They stay on the high ground. There is a low ground in between them, and the high ground is kind of the advantage position. And so they try to stick to the high ground, and they exchange blows. They kill some monsters coming at them, and they try to fortify their position. And so what our new hot-off-the-press bot did right at the start of the game was it walked straight into the river and just stood there. And the monsters would come, and they would hit it, and it just stood there. So our professional player looked at us and said, well, it's broken. And we're like, yeah. But just for formality, we asked him to just finish it off, just to see how he responds. He was like, come on, it's a waste of time. But eventually he agreed, and he just kind of went to deal the finishing blow. And at that time, the model turned around and won. So that was a bit of a shock, right? It was a shock to us, more of a shock to the pro player. And then he tried again and again and again, and this repeated a couple times. And these attempts were increasingly frustrating for him, and also he increasingly gained respect that maybe this bot wasn't actually completely broken, that maybe it was capable of something. And eventually he defeated it. But what we understood happened was actually the bot was not broken, but rather because of the increased time horizon that was optimizing, it learned a new strategy. And the strategy was baiting, so pretending that it was weaker than it was. Because of this longer reward horizon, it understood that if it plays weak, okay, like it's not going to look great 10 seconds from now, right? It's going to be in a disadvantaged position. But if it manages to catch its opponent off guard, if it manages to make the opponent go out of position, it will be in a much better position a minute from now. And this worked extra well during its training, as it was playing against copies of itself that have never seen this behavior before. And so the next day, as the bot kept playing against itself at learning, it actually learned to counter this strategy. And then it played normally again, but it was much, much stronger than ever before. And actually, during that competition, we ended up winning all the matches against the professional players. So that was a bit of a nail-biter. A year and a half later, we have defeated the top professional team at a 5 versus 5 version of the game by continuing to scale and improve this system. And we were also curious about, can we apply the same methodology to other domains, right? If it works so well in this continuous real-time game, well, we applied it to robotics also. So the same methodology, we used Rapid, and we actually trained a robotic hand to manipulate a cube and then a Rubik's Cube, and really started getting confidence in this power of scaling deep learning. Now, going towards the last part of my talk, as we were working on Dota, there was another exciting development happening at OpenAI. Ilya long had this dream of training a large model in an unsupervised way on a large amount of data. And Alec Radford was pursuing that dream by training unsupervised language models. And he had a truly remarkable result that I think was the first real indication of what was to come. He took a recurrent neural network. So that was before the famous transformer architecture, actually. He took a recurrent neural network and trained it to predict the next word on Amazon reviews. So it would just be a large collection of Amazon reviews, and the model would just read the review, and all it would try to do is predict what is the next word. And he demonstrated that once you make this collection of data large enough, and once you make the recurrent model large enough, it actually learns to recognize whether the review it's reading is positive or negative. And that was a huge deal. You see, in 2017, language models didn't sound the way they sound now. And when you heard the phrase language models, you felt more like, oh, this glorified grammar machine. And people had suspected that maybe when you push them enough, they will be able to model more than just the basics of human grammar. They will be able to do more than just like put two words together that, in a way that maybe sounds coherent. But I think this was the first clear example that, yes, they can actually get the meaning of the text just from this unsupervised training. And then the transformer architecture came out, and that was a huge compute efficiency improvement. And then came GPT-1 and GPT-2 and GPT-3. And from this line of results, I think a particularly beautiful result is scaling laws on neural language models from Sam McCanley, Jared Kaplan, and others, where they showed that you can actually predict, as you increase compute, how much better the model will get at at predicting the next word, at the objective it's being trained on. And you get this remarkably beautiful law. And I think this is a fantastic result. And also, I think it's really a great illustration because it's not so much a result in mathematics, right? You cannot really prove it. It's an observational study, and it's very much like a law of physics because it combines mathematical principles with some properties of human language and some properties of deep learning that we don't have a great theory of. Sometime later, we embarked on the biggest scaling challenge yet, training GPT-4. And as I talked about today, when you really try to scale a deep learning system to these unprecedented levels, your understanding of every component of the system really gets tested. And so we realized that if we want to train a really great language models, we really need to get our foundations right. And so we focused on all layers of our stack, from hardware to great engineering, software, all the way to algorithms. And to verify our understanding, we made predictions about what the model would be able to do. So actually, based on much smaller experiments, we were able to successfully predict how good GPT-4 would be at solving a collection of coding problems. And I think this is a nice result about our predictive methodology, right? Oh, like this methodology works to predict something about the model. But I think more importantly, it serves as a good test of our ability to scale. And it actually shows that the compute we spend for the model is spent well, and we are actually getting something in return, and we can be fairly confident that we're getting a model roughly of the quality that we should expect. And we did get a pretty good model. And based on GPT-4 and a smaller model called GPT 3.5, we released this tech demo called ChatGPT. When we released ChatGPT, we've already been using GPT-4 for a while internally, and we had some preconceptions about how strong AI should be, and we didn't really think that ChatGPT, especially based on the 3.5 version, would be that useful to people, and we thought it would be more of a kind of cool toy for people to look at. And of course, we were overwhelmed with how useful people found it and how great the adoption was. And that is roughly where we are now. But again, as I said at the beginning, I really believe we're only seeing the first steps of what this deep learning technology is capable of. And I think we're in for some exciting years. It's really a great honor to be here and a great opportunity to share this with you all. Thank you very much for listening. If you have any thoughts or questions, please let me know. Thank you.
Hey, thanks so much, Jakob, for that talk. And we do have some time to take questions for the next 5 or so minutes. Because the room is so big, if anyone has a question, what I'll ask you to do is please come in front of the stage and line up in front of these the red ropes here, parallel to these red ropes in front of me. So anyone who has a question, please come up. Thank you. No one? Okay.
Can I ask two?
I think there's time. No one else is lining up. Maybe people are.
Yeah, the first one is related to looking back, because I felt it was interesting that the route you took to reach the point you have with chat, starting with the max flow, starting with convex optimization. If you hadn't walked that path in that steps, you might not have reached the same conclusions. Would you agree with that, and how would you reflect on it?
I think so. The question is, if I took a different route, would we have been able to reach the same conclusion, or would I have been able to reach the same conclusions? I definitely think that this journey, starting from programming competitions, and which heavily influenced my thinking about theoretical computer science, and then theoretical computer science, which heavily influenced my thinking about deep learning, definitely shaped how I think about this space of problems. But I think for a company like OpenAI, the thing that's really important is people coming from different research backgrounds and all these different ideas about how things work combining.
Yeah. And the second thing is related to, of course, GPT-5. I guess we can expect it this year. Like, on order of magnitude kind of improvement, can you give us a feel for it?
Well, I think maybe like the best answer is on this plot. I don't think we've really seen great evidence for these scaling laws slowing down. And like when we were training GPT 3.5, I guess with each of these models, you kind of expect, well, you look at GPT-3, it's pretty smart. Like you cannot really get that much smarter, right? Like we're about to hit a wall, and then we train 3.5. Oh, it's actually much better. Okay. Well, GPT-4 is probably going to be a dud. And at some point, you actually start accepting the idea that maybe this high-dimensional optimization procedure is actually going to keep producing smarter and smarter things, because that's what the empirical studies tell you.
Forever? I mean, is there no diminishing return kind of scenario that you foresee?
Maybe just because of the time, I think now we have some more people lined up. So.
Yeah, I was trying to.
Okay. Okay, thank you, though.
Hello, yeah, I'm curious, how did you find the bottleneck or the bug in a very large and complicated system?
Sorry, could you repeat?
Yes, sure. I'm curious, how did you find the bottleneck or the bug in a very large scale, like complicated system like GPT or something?
Yeah, so I think it really comes back to this, to a very similar insight that I described at the beginning in programming competitions, where, originally I thought like programming competitions are about avoiding bugs, right? So you kind of have this idea on how to solve a problem and you avoid bugs. And I think it really comes back to this, to my revelation from how Petra approached problems, that it's less about, oh, you just have to kind of avoid bugs in your messy solution, but instead you have to make your solution really reflect a deep understanding of the problem. And when you really get the foundations right, at some point there isn't as much room for bugs, right? So it's less about, oh, it's going wrong, what should we fix? And it's more about what don't we understand, and you look for ways to improve your understanding.
Sure, I see. Yeah, thank you.
Hi, we have seen AI models win chess players, the best chess players in the world, also to win the Go champions. And I was wondering, how long do you think it will take, for example, to put an AI model in this competition?
Yeah, I think that's a great question. I think we might be fairly close. It's hard to make exact predictions here. Although we did make exact predictions about much easier coding problems than we face in this competition, and and GPT-4 was able to make substantial progress on those. And I think definitely it is possible to do much better than GPT-4, and we'll see models far more capable than GPT-4 at coding in the near future. So I think it may be a matter of years.
Hi, thanks for the nice speech. It's somehow the question relevant to the previous question. Yeah. Do you think in 5 years whether ICPC will be relevant or not anymore? Because if the computers can solve better than humans, I mean, then why do we want to write the program? They can write better things. And what should we do at that time? And as you know, like you mentioned about AlphaGo, but now there are alpha geometry that they can solve IMO very well, at least the geometry problems. Yeah, so what would be your, idea for 5 years from now? Should we still doing the ICPC, or maybe we should find some other things? And what would be that other things?
Yeah, So the question is, will ICPC still be relevant 5 years from now as AI continues to get better and maybe becomes able to tackle some of these coding problems? I think the question of how AI will impact what we do and how it impact what tasks we find valuable it's a very important and tough question. And there definitely are professions that are already impacted by AI quite heavily, and I expect there will be many more in the future. ICPC, I think, is quite safe because it's really about learning and it's about the community. So I think Dota community carried on just fine after our Dota bots.
From what I saw, the transformer model was one of the biggest breakthroughs that allowed ChatGPT to be so powerful. And I was curious, do you think we've reached the limit of the transformer model? And maybe are there any other models that you're looking at for the next, not GPT, but something else?
Yeah, transformers were a huge breakthrough and really increased the compute efficiency of these models a lot, and definitely enabled this GPT research program. Although, as I mentioned, like there were results about models being able to learn semantics even with older architectures. I think the incredible thing about transformers is how it's really a good architecture for the kind of hardware that we use. It parallelizes very nicely on GPUs. I think there are improvements possible, right? And I think we will see some improvements in the future, and I think we've already seen some maybe more incremental improvements to this architecture lately. I think with enough time, I would definitely expect there will be just a complete revolution and a complete change of paradigm. I think the question is, how far will the current paradigm get, which seems to be going quite fast.
Hi. So I think there are currently quite a lot of people who have a really negative outlook on AI and both short-term societal impact and potential catastrophic events in maybe slightly further future. I'm just wondering if you have any personal thoughts on, are you scared for anything bad will happen from AI, or are you just a positive outlook on all the benefits it could bring?
I think the question of the impact of AI and AI safety is incredibly important, and at OpenAI we view it as a core part of our mission. So for example, before releasing GPT-4, we actually had this model for half a year, and we tested it, and we studied how releasing it would impact society and ways to mitigate risks around that. And of course, as these technologies become more powerful, this becomes even more important. I think the benefits that AI can bring are incredible. And really so far, we think of AI more as assistants, but sufficiently smart models can actually help us with research and with medicine. And I think it will be incredibly hard to discard these opportunities. But yeah, thinking about especially the potential for misuse in the short term and the potential for bad things happening is definitely top of mind.
So I wanted to ask about these big neural networks, models like ChatGPT and DALL-E that create new things. Do you think that they are actually creative, that there will be a moment that they can actually surpass human creativity, that will actually use it instead of artists and scientifics?
Use it instead of?
Artists and all other creative people.
I think it would be very hard to bet against deep learning eventually being able to surpass human ability. In the past, it seemed like it would be hard for computers to beat humans at chess. It seemed like it would be hard for computers to beat humans at Go. It seems like it would be hard for computers to ever speak coherent sentences that actually have meaning. And all these things surprised us as compute continued to increase at some approximation. So I expect we will eventually face tough questions about AIs that actually are able to do some important cognitive tasks at human level.
Hello. A lot of the discussion around ChatGPT and large language models in general have been based around whether they can really think, or are they just stochastic parrots? A lot of people call it that. But I want to ask that if they're really able to think, do you think with sufficient scaling, an AI large language model will be able to solve a chess game as good as a specific model like Stockfish is able to solve?
Yes, I expect this sort of technology should eventually be able to achieve that.
And how long do you think that would take? Like 10 times the compute power, 100 times the compute power? Because I see it making a lot of mistakes. And in a chess game where you have to make multi-step reasonings, it's very easy to just get one piece wrong, and that completely changes your game.
Yeah, so I think there's a question of how long this particular paradigm of scaling language models would take to reach that level. And I expect it eventually would, although I expect by the time we would get there, we will find alterations of the paradigm and new methods that will actually get there faster.
In the interest of time, I think we're just going to have 2 more questions, okay?
Hello. So my question is, how much do you weigh like the pros and cons between choosing to open source your models versus like keeping everything closed under the hood?
Yeah, that really comes back to this question of the immediate impacts of AI. And so similar reasons as we decided not to release GPT-4 for half a year, we've become increasingly strict about publishing our research and open sourcing our work. Because when you're working on these cutting edge things, we feel a great responsibility to actually, on one hand, we do want the world to engage with them, but we also feel responsibility for the ways it can be misused.
Thank you.
Hi. So the silver lining of your talk was about having strong foundations because they help you, in the specific case that you mentioned, to scale your models properly because you can only do it almost once. So I have a couple of questions regarding that. For example, sometimes I believe it's not possible to, if you see some result, you do some ablation studies, you see the result, the numbers, but the intuition behind it, the reasoning behind why this is the result may be different from different people or persons, so there's sometimes maybe disagreement. The other thing is that, for example, with the scaling laws, as I remember, they were rediscovered sometime later because there was multiple papers. One had one result, the later one had different result. So the question is, how do you deal with this kind of uncertainty and, well, yeah.
I mean, if you're referring to the later scaling laws results of Chinchilla from Google, I think that's a great example actually of something where like you get a result in this original scaling laws paper, but maybe there are gaps in your understanding that when you fill them out, you actually get a different result, and it actually allows you to scale further and reach better performance. So I think that's actually a good example of the importance of studying. I think scaling laws, right? Like this study is kind of one layer of the system, but there are multiple other layers that we also need to understand to really make the scaling robust.
Thanks.
Oh, hold on.
your mic is off.
Well, thank you very much. This was a really excellent talk. Thank you, Jelani, for arranging this, and Jacob for sharing your journey, your experience, and quite interesting stuff up here. I actually had a question about the neuron model there, but I started thinking, wait a second, I don't get to do that anymore. You know, I'm a granddad. But anyway, so you know, one of the students came up and said, "Well, do you think I might be able to ask Jacob, you know, a question later?" And I said, "Well, you know, he's a 10-year-old." Older version of you, so I think Jacob would probably enjoy a little bit of interest. So thank you for a really excellent presentation here and presence here, and thank you, Jelani, for being a leader in the ICPC alumni, the leader of the ICPC alumni program. So I would like Jan Mahdi to come up here, if you don't mind. Jan is the senior coach, 29 consecutive years a coach of the ICPC World Finals, and then the three of us, the other three, okay, with the four of us, then we'll make the coach awards. So Jan, come right up. Jan, do you know Jelani here? All right, and of course, I'm just kidding. Do you happen to know this guy here?
I met him once or twice.
Oh, okay, because you were his coach, okay, along with others who are wonderful. So anyway, is it time now for us to start the Coach Awards? Oh, it is! Oh, my goodness, and I even have a script here. Are we supposed to speak behind here, right here? And so you are the receiving line for the coaches, and then also the parentheses in a Lispian way to bring them together to get our pictures, okay? So here we go. At this time, we'd like to honor this year's recipients of the Coach Award. It's because of their dedication, commitment, hard work, and personal sacrifice that we are here today celebrating the best of the best. Coach Awards are presented to coaches who brought teams to the World Finals 5 or more years. Master Coach Awards are presented to teams who have brought, coaches who brought teams to the World Finals 10 or more years. And Senior Coaches are presented, awards are presented to coaches who've brought teams to the World Finals for 15 or more years. And Lifetime Coach Awards are for those coaches who brought teams to the World Finals 20 or more years. And I guess we're going to have to come up with some other category for somebody who's brought teams to the World Finals for 30 consecutive years. And thank you, Jan, for being the ICPC senior coach here today at the ICPC World Finals. So today we have 30 coaches receiving these awards. Coaches, when your name is called, please come to the stage to receive your awards. We will begin the Coaches Award now. Our first Coach Award is being presented to Abhishek Shrivastava from IIT Indore. Coach Shrivastava, please come forward. He's brought teams to the World Finals 5 times. Coach, where are you? Please come forward. Coach. Here, Coach. There, Coach. Coach. No. Okay. Coach is from IIT Indoor. Is he here? Okay. All right, we'll go on to the next one. All right. He just stepped out. It's a long way to the powder room. So, Anna Varapa Shanda Sekara Rao from IIT ISM Dhanbad. Coach Rao has brought teams here for 5 years. Coach? All right. Coach Rao, just come right on up here to the greeters. Receive your award from the ICPC Senior, and stand in the middle if you don't mind. We're going to get you right in here, and you can't escape. Thank you. All right. And now we have our third recipient, Badra Shalom Shaturi from the University of Texas at Dallas. Come on up. That's what we need, is a Texan to come up here and receive his award for bringing teams here 5 years. Shaturi, are you here? Well, I know he's here in Luxor, but Shaturi? Okay, we will catch him later. All right, the next coach is Etienne Voga from the University of Texas at Austin. Coach Voga has brought teams to the World Finals 5 years. Coach, come on up. Here we are. Congratulations. Congratulations. And right there. Oh, okay, this is perfect. All right, and we have Etienne Voga from the University of Texas at Austin. What happened? Huh? No, I'm not. Oh, I see. But Coach Downing could not be with us today. Coach Downing has brought 5 teams. Okay, here I'm terribly sorry. I just skipped ahead here. Hey, Glenn, are you here? Okay, sorry. The next coach, Glenn Downing, is also from the University of Texas at Austin. He could not be here with us today, but Coach Downing has brought teams to the World Finals 5 times. And so if you don't mind, Coach Voga, if you could accept his trophy as well. So just hold that one up for Glenn, and I hope that he can come back very soon. He's a wonderful, wonderful ICPC volunteer. Okay, thank you very much. All right, and so now we have Guangzhong Sun, okay, from the University of Science and Technology of China. Coach Sun has brought teams to the World Finals 5 times. Coach, come on up. Let's get that photo up. Congratulations. And now we have the next coach we'd like to recognize, and that's Hadrian Baral from École Normale Supérieure. So please come up, Coach. 7 times to the World Finals. Thank you, Coach. All right. So, and now we have Hamid Zarabi Zada from Sharif University of Technology. Please come to the stage. Coach has brought teams to the World Finals 7 times. Coach? Okay, Coach, anywhere? Okay, all right. But thank you, and let's remember his wonderful accomplishment. And now Jun Ma from Nanjing University. Coach, 6 times he's brought teams to the World Finals, and so far he's the favorite. You could hear it in the crowd. Thank you. And now we have from Federal University of Rio de Janeiro, we have Coach Marcia Serioli. Come on up. All right, Coach. And it's, of course, Rio de Janeiro. I mean, every Texan knows that, but, you know, my tongue doesn't work always. Thank you. Thank you. Thank you. And now we have the next coach we wish to recognize, and that's Badix Beckman from the University of Illinois at Urbana-Champaign. Coach Beckman has brought 6 teams to the World Finals. All right, and now we have from the American University of Beirut, we have Coach Nagi Nahas, who has brought teams to the World Finals 5 times. Coach? Congratulations. And now, let me introduce from Indian Institute of Technology, Karajpur, Pawan Goyal. Pawan? Good. Coach Goyal has brought teams to the World Finals 5 times. Accepting on behalf of Coach Pawan Goyal. The next coach to recognize is from UNSW Sydney, a stalwart of the ICPC, Raveen De Silva, who's brought teams 6 times to the ICPC World Finals. Thank you. And now, let me present to the coach of IIT Madras, India, Rupest Nasra. Rupest Nasra. Perfect. On behalf of the coach, on behalf of the coach, Rupert Nasra. Thank you. Let's have Vikram Pudi from International Institute of Information Technology, Hyderabad. Please come to the stage. Coach Pudi has brought 5 teams to the World Finals. Okay, and you're here on his behalf. Excellent, excellent. Thank you, AtoQ. So here, on behalf of Vikram Pudi. Next, we have from the International IT University of Northern Eurasia, Yeskinder Sutanov. Okay. 5. Okay, he's not giving. Okay. On his behalf, 5 teams to the World Finals. The next coach is Zach Frigstead from the University of Alberta. Zach has coached 7 teams, 7 times to the World Finals. Zach? I'm so glad to see you here. The University of Alberta, 2008 World Finals host. Our last coach for this coach award is Zizan Zhang of Sun Yat-sen University. Coach, yay! 7 times, 7 teams to the World Finals. Congratulations. And now for the Master Coach Awards. Master Coaches have brought teams to the World Finals 10 or more years. And the first one up is Master Coach Anton Pankreativ from Lemonovsk Moscow State University. And he's brought teams to the World Finals 11 times, and his dad was a coach of extraordinary capability, so thank you. Second generation coach. Thank you. All right. And here we have Glenn Martin from the University of Central Florida. Coach Martin has brought teams to the World Finals more than 20 times. Glenn, so glad to have you. Glenn Death Star in the heavens. Thank you. And now, from Peking University, Guoji Lao. Guoji has brought teams to the World Finals 10 times. Guoji, are you here? And was the deputy director of the ICPC World Finals when we were in Beijing in 2018. Guoji, yay! Congratulations, Guoji. Guoji does workshops as well. Thank you very much. Next is one of the most prolific coaches of all time, who's extended his reach to youngsters and attracted them into the ICPC channel. And that is Mohammed Mahmoud Abd El Wahab Mohammed Abd El Monem darn it. I swear I thought I was going to get this right. Mahmoud, from the Faculty of Computers and Artificial Intelligence, Cairo University. Coach Mahmoud, come on up here. 18 teams in the World Finals. So, yeah, let's zipper out and let's just step forward. Here we are. Coach Mahmoud. Thank you, Coach. Now, this is our first year awarding the Master Coach. So I'd also like to bring forward both Master and Senior Coach, Pujin Cheng from... Oh, hold on. Let's hold that in suspense. Oh, okay, good. Okay, from Tsinghua University, Xiaojun Wu, come on up, Coach. 19 times, 19 teams to the World Finals. Coach? Extraordinary, thank you. And our last coach in this category is Yu Song from Beihang University. Coach Song has brought teams to the World Finals 10 times. Coach Song. Thank you, Coach. Thank you. Great. Coach Song. Oh, whoops. Now, this is the first year we're awarding the Master Coach Award. We have 5 coaches who will receive 2 coach awards. Master and Senior Coach Pujin Cheng from National Taiwan University, Coach Ching has brought teams to the World Finals 17 times. Here he comes. Coach. Coach Ching. No. Coach Ching. Doggone. Let's see. Can we have a team member to accept this on behalf of Coach Ching? National Taiwan University. National Taiwan. Yeah, come on up, guys. You can, all of you come up here because Coach got you here. Okay. We'll ask him to take it back to okay. Come on up. Let's form a yep. We'll form a line here, guys. Yeah, here we are. Thank you very much. And now, Master and Lifetime Coach, having brought teams to the World Finals 21 times, Andrew Lapatin and Anna Lopatina from St. Petersburg State University. Please come up. Is Anna here? Oh, okay. That's her. Oh, congratulations. Next, we have Master and Lifetime Coach Andrew Stankovic. Andrew Stankovic, actually, from ITMO University. Coach Stankovic has brought teams to the World Finals 20 times. Coach? Good to see you. From ITMO that has more medals than a California gold miner. Thank you. And the last coach receiving both Master and Lifetime Coach Awards is from the University of Wisconsin, Madison, Dieter Van Melkebeek. He has brought 21 teams to 21 World Finals. Dieter, come on up here. Dieter Van Melkebeek. And that wraps it up for all of the coaches you see up here at different times in our lives, and for these wonderful coaches that make life bloom in the ICPC. Thank you very much. Bye-bye. Okay, we're going to, okay. Oh, answers to questions? Oh, it's John's turn. Here, let me give you a hand. You've got the con, I'm going to go hide.
Thanks, Bill. So now we're going to do the answers to questions that were asked through the Dom Judge clarification system. First question was about printing things with banner pages on them. If you send a print job, do not add a banner page to it. Our system adds a banner page, and if your banner page is in front of it, we won't see our system banner page, and we will therefore throw your print job away. So do not select banner page when you send a print job. Hold on just a second. There were a number of questions asked during the dress rehearsal that are system specific. They have to do with the Dom Judge contest control system. And at this time, I'm going to turn the mic over to the leader of the Dom Judge team, Toby Worth, and he'll answer those questions.
Thanks, John. So let's start with some more general systems questions that you asked. We posted the image that we are using here ahead of time. We do that you can test the image. You can still do that, download the image and test stuff. So some of the configuration settings, you can try them yourself. You can also Google them now and try them in the open practice later. That especially applies to all the IDE configuration. We will not help you to set up Kotlin, unfortunately. We apologize. You have to figure this out on your own. The same for all other IDEs. There were some questions about code blocks, etc. Please figure this out during the open practice session. You can use your phone to Google during the open practice and set the settings. They will be lost, but repeat the steps tomorrow. We will not install additional Python libraries that were requested very, very late. It might be possible to disable paste on middle click. I actually have a command here that might work or might not work. So if you want to try, I'll leave this here and you can take a photo of it. The same is true for keyboard layout. Try it out during the open practice. Google it. As a standard Linux system, you should be able to change the keyboard layout with standard tools. Some people asked, where is the language documentation? There's a menu item which is called programming, and that has a documentation sub-item. There you can find the documentation. Now to the more Dom Judge and judging specific answers. The sum of all files that you submit to Dom Judge is limited to 256 kilobytes. We don't think you need that much, but you can't submit more. This and other limits are specified in the Dom Judge team guide. And going through all your questions, it may be a good thing to read that guide before tomorrow again. Be aware that when submitting multiple attempts in a short period of time, as some teams did today, your submissions will be down prioritized in our judging queue. So you may receive results later than other teams. In other words, if you spam us and have multiple runs outstanding, your judging will be slowed down. Of course, we appreciate that you test this during the dress rehearsal session. Tomorrow, if you exceed limits beyond reason and endanger the success of the contest, we will take measures. In DOM Judge, you can enable notifications for clarifications. Unfortunately, for submission results, there is no such thing. As you might be aware, DOM Judge is open source. There's a GitHub issue, number 2252. You can go to GitHub, upvote it, or even better, send us a PR to fix it. We won't deploy it for tomorrow, but maybe next year. Pragmas in C++. Some teams use pragmas. These are allowed if you want to use them. If you don't know what these are, don't worry. We think they won't help you. The hardware of the machines evaluating your submissions is identical to your team machines. They run the same operating system, the same base image, but they're tweaked a little bit to make run submission times more consistent. For example, we pin your submissions, the execution of your submissions, to a single core. We also run in a sandbox. All of that we do to run it in a controlled environment. So it will not be exactly the same, but similar enough to say the machines are identical. We will run your submissions on the test cases in a deterministic order. That means if your program fails on the 4th case with wrong answer, and on the 5th case with run error, DOM Judge will report wrong answer. We will not report the number of the test case that failed. We will only say wrong answer. So that means if you get a wrong answer, you might have other bugs in your code that do not show up yet. There is no specific memory limit verdict. It will be reported as run error. We got like 50 questions around memory limits and stack size limits. All of that should be in the documentation, but I will repeat it here. For C and C++, the stack size is unlimited, except for the global sandbox limit of 2 GB. For Java and Kotlin, the stack size is 64 megabytes. For Python, it's the default. Memory that is allocated but not written or read might not count towards the memory limit, but we do not guarantee this. So if you allocate a super large array but don't use all of it, it might work, but there's no guarantee. We also think you don't need this. For interactive problems, only your code runs in the sandbox, not the interactor part that runs outside of the sandbox. So that part does not count to memory limits or other limits. There is a command line tool installed called Submit. If you haven't tried it during the dress rehearsal, you can try it during the open practice. Just run submit -- help to learn how it works, or read the DOM Judge team guide. You will also be able to download the source code of previous submissions tomorrow, as you were able to do this today. We will not change this configuration option. During the freeze, which will likely last 1 hour, you will still be able to see the result of your own team's submissions, but the results of the other teams will not be visible. So you will see they submitted, but you don't know what the result of that is. And lastly, there will be an online judge, but we don't give any guarantees about the performance compared to the machines locally. And now I'm handing the microphone over, I think, to John from the jury.
Thank you, Per. We just have sort of 3 questions we need to respond to. The first was, are Python solutions guaranteed for all problems, and is there a modified time limit for Python? Per the contestants' rules, the judges only guarantee solutions for at least 2 languages. So maybe Python, maybe not. And time limits are the same for all languages, so independent of what the language you use. Second question, on interactive problems, is the presence of an interactive tester program guaranteed? All we can say there is that if there is an interactive problem tomorrow, there will be an interactive test program. You can see the judge's notes addendum for the location of this test program. Finally, and the most popular question asked, will the 46 and 47 finals have the same problem set? Our answer, wait and find out tomorrow. And I now hand it to John.
Thank you, John. Okay, the final set of questions were general operations and systems questions. I'll go through those. A number of people asked about the displays that had colors and letters and numbers, but there was no explanation of what the numbers was. They'll fix that tomorrow. There'll be an explanation, but in case you just desperately need to know because you won't be able to sleep tonight, the numbers that were up there were for each problem, the number of submissions made, the number of accepted submissions, the number of rejected submissions, and the first solution time for that problem. Someone else asked a question about the colors on the scoreboard, in particular dark green. The dark green color means that accepted submission was the first solution to that problem. Someone asked about the mouse pads. Can we take the mouse pads home? Tomorrow, at the end of the contest, the answer to that will be yes. You can take the mouse pad home. But do not take it home today because you won't have one tomorrow if you take it home today. Okay? Can we ask for extra pencils during the contest? Yes, if you need a replenishment of the supplies on your desk, water, pencils, paper, pads, raise your hand and one of the deputies or runners in a white shirt will come and bring you that. Can we ask for extra scratch paper? Yes, if you run out, we've provided pads on your desktop that have lined paper, blank paper, and graph paper. But if you run out of that, ask and we'll give you more. If we want to go to the toilet, what is the exact procedure? I'm not sure how much detail I want to go into this. But I believe that the question was in regard to how to get from where you are to the toilet. And in that regard, the teams that are in the 46th annual contest, all of you people over on this side, go out that door right there. And the toilets are right outside. All of you people in the 47th contest, go out that door and the toilets are right outside. The question was asked, can I use the 47 toilet if I'm in the 46 contest? No, they're separate contests. You have to use separate toilets. The question was asked, do I have to raise my hand to go to the toilet? No, all you have to do is get up and walk out the proper door, and you can use the toilet out there. Will balloons be delivered faster tomorrow? I don't know what's the weather going to be like tomorrow. It's the same kind of question. We deliver balloons as fast as we can. Believe me, there's nobody sitting back there saying, hey, let's hold on to this balloon for an extra 10 minutes just to make this team irritated. Okay, we are doing the best job humanly possible dealing with the fact that we have basically the same staff that we run a World Finals with, and we're running two. So we'll give you every best effort that we can. We will get things out here as fast as possible. I will say this, that print jobs take priority over balloons. So if somebody sends a print job, we will bring that out before we bring balloons out. Will a calculator be provided tomorrow? Well, there's a calculator on your computer desktop, but yes, there will be an actual physical calculator on your table tomorrow. Just a very simple 4-function type calculator. Can we bring one ourselves? No, you cannot bring any kind of electronics onto the onto the contest floor. Can I use an abacus? Because that's not electronic. And the answer is yes, if you checked it in at team registration and said this is part of our team supplies. Otherwise, the answer is no. Can we touch food and drinks before the contest? When you come in tomorrow, your lunches will be here as they were today. You may take them off your chair, set the bag down on the floor, and sit down. So yes, you can touch the chairs, you can touch the lunch bags. Let's see. There were a question asked about what are the links to the live stream and the online mirror. All of that information is available at icpc.global. All you have to do is go there and you can follow links. Air conditioning. Can it be colder? Can it be warmer? It's too hot, it's too cold. There's no way for us to take the average body temperature of everybody in this room and decide what is the perfect temperature. And even if we could do that, we don't have the equipment to do that. We are doing the best we can to establish a comfortable environment for everybody that's working. Can we bring an umbrella to the floor? I presume that this was asked because there's a walk in the sun from the staging area down to here, and people wanted umbrellas. And the answer is yes, you can use those umbrellas here, but it's gonna be taken away at the door, and we're not gonna keep track of it for you. If you have your coach available to hand it to them, yeah, you can hand them your umbrella. Otherwise, you're gonna lose it at the door. You cannot bring it on the floor. What if the lunchbox is missing items? What if we want more? Can we have more guava juice? Will there be any other food and drinks? Can we bring our own additional items? The answer to all of that is no. If you had checked in anything during team registration, as was announced months ago in the email you got, then that would have worked. You had the opportunity to put stuff in your registration bag, but you can't anymore now. If you need more water or juice, raise your hand and we will gladly provide it. Someone asked, can we take tissues with us? In other words, my nose is running. I need to blow my nose. Yes, we're not going to quibble about that. Can I get coffee at my desk? Yes, if you put it in your team registration bag when you checked in. Can I leave my earplugs in for the contest? There is an issue, actually, of wearing hats. Hats are allowed, especially the ICPC hats, but your ears may not be covered. We need to be able to see your ears. This is so that everybody else knows that you're not using an electronic device in your ear. Okay? However, if what you have is a non-electronic pair of earplugs, you may wear them if that's your desire, but be prepared for us to come up and say, take these out and show me that they're not electronic. As long as they don't have any don't stick your iPad, your iBuds in your ear. That's not going to work. Someone asked about one of the TVs making some annoying noise. We will look at that as soon as we can. There was a question about printed materials. Apparently, some teams brought some books or something onto the team floor. You may not bring anything onto the team floor other than what was turned in your registration bag. Do not bring any books or any other printed materials onto the contest floor tomorrow. Your team reference document should be on your workstation right now, and you should leave it there, and it will be there tomorrow. Do not take it with you. Do not take your team reference document with you. You will not be allowed to bring it back into the contest floor tomorrow. It would help if you would put your team reference document back in the bag that it belonged in. Because we are going to clean the workstations off. And if your team reference document just looks like a bunch of shabby paper, then they might just clean it away. Regarding printing, you can only print small jobs. Do not, as I announced earlier, do not print the scoreboard. Do not try and print the entire Java API or C++ reference manual. That will be considered an attempt to swamp the contest resources, and that's grounds for disqualification. There were a number of people who had cell phones or smartwatches or what have you on the contest floor at the start when I announced everybody hold up their phones, and a number of you were quite honest and held up your phone. Honest mistake. If you gave up anything either at Nile Hall earlier when you in the staging area or on the floor, it will be back in Nile Hall after this session. You can go back to Nile Hall and pick up anything that was kept or confiscated from you. When you leave the tent today, as soon as this session is over, after this session, as soon as we finish all the questions, the answers to questions, you are free to go as long as you leave your team reference document and so forth. But if you wish to have your photo taken with the trophy, you didn't get that previously, ICPC News will be taking taking trophy photos outside the tent until 7 p.m. Okay, so they'll be outside here somewhere taking photos, and you can get your picture taken with the trophy. So look for ICPC News and the trophies along the walkway outside of the tent. Finally, you may have noticed that during the dress rehearsal, someone came by and put an envelope on your table. If you haven't bothered to look inside, you can look inside there and you'll see that you have your very own personalized ICPC business cards. Those are for your use. You can take them with you. You can hand them to the wonderful sponsors that we have, Huawei, JetBrains, and all the others, and say, here's my card, how'd you like to hire me? Okay? That concludes the answers to question sessions. If you want to stay, we will, for the next hour, have the machines available and you can log in. If you want to submit something more to Dom Judge, you can do that. You can practice, you can check to see if any questions you have. Otherwise, you are free to go on to your next event. Thank you very much. And one final thing. Please make sure tomorrow morning you are at team check-in at the proper time so that you can get down here. Don't show up back here tomorrow. Show up at team check-in, the same place you did today. Good luck tomorrow, and we will see you all in the morning.